en el aire.
Good afternoon, everyone. My name is Stephanie Ollenarte da Rocha. I am representing AEACaP, the Spanish Association of Lung Cancer. I am very pleased to have to welcome you to this new webinar. Today's webinar is ROS1, and we are very happy to have Dr. Santiago Viteri, Dr. Benjamin Bess, and Meryl Hennig collaborating with us to make it possible. I cannot continue without thanking all the people behind this camera participating and watching us. Everything we do is for all of them. Thank you, Anjen, Bristol Myers Squibb, Boehringer, Ingelheim, Novartis, and Roche for the great collaboration. This action would not be possible without them. Before introducing our speakers, I'd like to talk about AEACaP. Created in 2008, presently named public entity. Our association works for lung cancer patients and their families to cope with the disease from the beginning. AEACaP provides different activities. I will name just some of them. Useful informative activities like today's webinar, clinical trial research, nutrition supports, scholarships. It also gives psychological and legal support, Facebook and WhatsApp groups to share experiences between patients and families. Different action to improve awareness and prevention. Also action to promote exercise, cultural activities, and much more. Everything for the patients, everything for our future. For those who have not connected before to our webinars, we simply would like to inform you that the objective is to inform you of this meeting is to provide useful and rigorous information from experts, such as the one we have today. Secondly, I'd like to inform you that what we want is to solve any doubts you may have during your illness as a patient or in your environment. We have already received many of them through the means available through email or registration. Thirdly, I will explain how the structures of this webinar. First, we will be able to enjoy the presentations for approximately 20 minutes each one. And then we will be giving all the possible information on this topic, ROS1, as we said before. During this time, you can ask questions or doubts through the means, as we mentioned before. And we will discuss them later with our guests. Now I'd like to give you a brief introduction to our guests, so all of you get to know their work better. We are going to start first with Dr. Santiago Viteri. He's medical director and co-founder of WOME Cancer, where he works as a thoracic oncologist. He also is the general manager of the clinical research unit Praxia Sirius. He specialized in cancer molecular biology, personalized medicine, thoracic tumors, and clinical research. In his case, focused on lung cancer and new treatment strategies. Dr. Benjamin Bess is the director of clinical research at the Gustave Roussy Institute, professor of medical oncology at Paris-Saclay University in France, chair of the European Organization for Research and Treatment of Cancer, and coordinator of the French Network for Thymic Malignancies. His research interests focus on the application of personalized therapeutic strategies based on molecular abnormalities, circulating biomarkers, and early drug development in thymic malignancies and thoracic tumors. And last but not least, we have Meryl Hennig, who will moderate this webinar between them. She was diagnosed with ROS1 lung cancer in 2014. After a few months, she became active as a patient advocate, first on a national, but soon on an European and global scale. In 2015, she joined the international Facebook group of people diagnosed with ROS1 lung cancer, the ROS Wonders. I hope I'm saying it right. A group connecting people to get more knowledge and to drive research to get more treatment options. She founded Stinking Matter Well to drive a patient-driven research project in Europe. Welcome, thank you. Santiago?
Okay, thank you very much, Stephanie, for your words and for your kind introduction. And also, I would like to thank the AEACaP for organizing this webinar and all my colleagues and the sponsors. So, well, let's see if we can update a little what we know on ROS1 lung cancer and the potential treatments. I was honored to be invited in a webinar like this 4 years ago. I was checking my records, no, and I was trying to think how the aspects have changed, how have we evolved in the treatment of ROS1 since when I prepared the slides of 4 years ago. So in my presentation, I want to make some reference to what I was presenting 4 years ago and now, no. So I will share my screen now. And okay, this is it. Just a second. I can move this. Okay. So, well, the title of my presentation 4 years ago was this: specific needs of ROS1 patients, no? And I had some topics. One was I need to be diagnosed, but in this year we are changing a little. We were discussing some other things 4 years ago, but I will now focus on what is the best treatment, when it will be available for me, no? Because one thing are the clinical trials, and then when are the treatments available in your hospital. And then during these years, I have received this question from many patients, and I don't know the answer, but I think it's a very fair question. Is, can I stop the treatment at some point if I have a very good response, if I've been on treatment during many years and all the CT scans and everything looks fine? Can I stop the treatment? And this is a question I will try to reflect a little on. So I need to be diagnosed. Well, as we know, we are talking here about personalized medicine, and this is very important to understand that the first must is the need of a right diagnosis, no, right in time, precise diagnosis. No, we can do precision medicine in oncology if we don't have the precise diagnosis. But unfortunately, this is a slide I used 4 years ago of all the kind of tumors that can be ROS1 positive. And it's not only lung cancer, but of course, lung cancer is very frequent. So 1% of lung cancer is a huge number of patients worldwide. But as you can see, there are many other locations where tumors can harbor these ROS1 positive fusions or translocations or rearrangements, and maybe targeted with ROS1 inhibitors. But we need to know that what is the correct diagnosis of the patients we visit before we decide our first-line treatment. And this is yet, unfortunately, not happening in many places. No, 4 years ago, I presented like several research papers that they were assessing what was the availability of molecular testing, and we discovered that many patients were still not at that moment they were not tested for all of the potential targets that can be treated. But we may think, especially when we work in specialized centers or in reference centers or academic centers, big centers with clinical research, etc., we may have the impression that today every lung cancer patient receives a very fast and very precise and very comprehensive molecular diagnosis. And unfortunately, this may not be the reality for community centers or medium hospitals, small hospitals, depending on each country. No, this is a paper published this year where they analyzed around 1,000 patients, and this is in community hospitals in the United States. And as you can see, they are asking for the NGS for these patients, but they take more than 25 days to receive the results as a median. And in about 48% of the cases, they started treatment without waiting for the NGS results. And this is clearly not correct. No, we need to know the right diagnosis, and we need to make an important effort so we can rule out if there is a ROS1 positive case before we start any treatment. No. So this is something I will not just speak a lot more on this. I mean, we have now excellent techniques, but to be honest, in Spain particularly, I have been in a meeting last week gathering with other oncologists in different regions, and some of them were just explaining us that they have just started to use NGS testing a couple of months ago. It's not the case in Barcelona, it's not the case in Madrid, in big hospitals, but it can be the case in other regions that are not so developed. So we have to take this on account. I mean, we need to we have a lot of work to do still on the right use diagnosis. No, we need to fully complete the diagnosis of all the patients we visit, and if possible, wait until we have the results and to guide our decision based on these results. So what is the best treatment? Well, let me show you this here. This is a very nice slide by Alexander Drillo, what was published in these Nature reviews about ROS1. And what he imagined at that point, what could be the strategy, is still very valid 4 years ago, 4 years later. No? When we detect this ROS1 positive, we can use as a first-line therapy ROS1 TKI. And when we select which one ROS1 TKI, we have to think about these characteristics. No, is my ROS1 binding to the protein like type 1 or type 2? Does my molecule also block other kinases? This may cause side effects, or this may have some potential benefits even. What is the pharmacokinetics of the drug I'm using? It absorbs well, it goes, and does it cross the blood-brain barrier? As we know, the brain is a sanctuary for some medications, and we need drugs that penetrate the blood-brain barrier. So when we treat the patient, we may have a progression, and this progression may be divided in these subtypes. No, we can have extracranial progression or intracranial progression. If we have an intracranial progression, we need to improve our intracranial activity. So use a better ROS TKI if available, or we always have the chances to use chemotherapy. Immunotherapy is here, but now I think 4 years later, even when we don't have yet very solid data, we can say that most of the oncologists now think that immunotherapy the kind of immunotherapy we have now may not be useful in ROS1, at least in the first or second lines. Then I may have a problem of ROS1 acquired resistance. Then I need to use a better TKI that can be active in those resistant mutations. But then I can have a resistance that is caused by a different driver. Then I may need a combination. Or I may have a mixture of both. So I need to change my ROS1 inhibitor and then combine with something else. So I think this strategic plan on how should I treat the patient is still very valid. And let's see how has been the evolution of the discoveries, approvals, and investigations on ROS1. So it was surprising for me to find this paper and discover that so long ago as 1987, it was published, the first discovery of ROS1 gene fusion in cancer. So this is 20th century. Maybe I was 9 years old when they discovered this ROS1 fusion in some type of cancer. But it was not until 2007, I was already an oncologist then, that there was the discovery of the ROS1 gene fusion as the driver of non-small cell lung cancer. And fortunately, some of the drugs that were in research at that moment were active against ROS1, and that led to the first approval of crizotinib in 2016. Crizotinib was approved not based on phase 3 trial, because ROS1 is infrequent, so it's very difficult to enroll enough patients to create a phase 3 trial with very big arms of patients, comparing maybe chemotherapy that was the first line against crizotinib. But based on phase 2 data, But this is very important because this is an important paradigm for other rare diseases that maybe may need this kind of approach, like approvals not based on costly and in time and money and number of people participating in clinical trials, when we can already understand that the drug is active and non-toxic for patients. Then we got the approvals for entrectinib, which is an evolution, a new TKI, seeking to be more potent and particularly more effective in the brain. And also, we started to recommend the use of lorlatinib, but interestingly, lorlatinib doesn't have FDA approval or EMA approval. It's just that we know that lorlatinib is effective. That was proved in phase 1 trials. And it's been used, but not with an approval, but out of label, in fact. But this is important because we know that ROS1 protein can be very similar to ALK protein, so many ALK inhibitors can also be ROS inhibitors, and this has been used in the clinical setting. And this red line I draw because this is more or less what I could explain in the seminar 4 years ago. But now we have a new approval of repotrectinib, a very potent and very penetrating ROS1 TKI, and we have 2 very promising new generation ROS1 inhibitors that are taletrectinib and zidesamtinib. And I will comment now on the results of these last 2 because they have been presented in the very recent medical conferences like the World Conference of Lung Cancer and the ESMO meeting. So please, you can see here in this chart, I don't want just to read everything, but well, the number of patients that have been treated in different trials with crizotinib, the overall response rate, meaning the percentage of patients that obtain a significant reduction of the size of their tumors, and the progression-free survival, meaning the median time the treatment was effective until the progression of the disease. And then you can see a summary of some particular adverse events. No, as you can see there, we are struggling to increase the number of patients evaluated in the clinical trial for the new ROS inhibitors, and we have been able to increase this overall response rate. Okay, as you can see here, from the around 70% of the trials in crizotinib, we have reached to the outstanding 90%. Response rate on taletrectinib. No, well, so this is more or less the advances we've seen. No, we have been trying to increase the potency of the drugs. You can see here ceritinib and brigatinib that are labeled for ALK positive tumors, but as I said, they can be also active in ROS1 and they have been tried, but they are not in the main line for the choices we can use for this. This table summarizes the results for naive patients, okay, patients that have not received previous TKIs. And this table summarizes what happens when we try to use these drugs in second or later lines, meaning that most patients receive crizotinib in the first line, or maybe entrectinib after the FDA approval, or even repotrectinib. But then what can we use? And then we can see that we have a possibility to rescue these patients using better ROS1 TKIs, better because they are more active for some of the resistant mutations, or because they are more active in the brain. And as you can see here, it is still very good to see that the new potential drugs that are on development have very good results in overall response rate for patients that have progressed to crizotinib or maybe some more inhibitors. So what do we know? This is a slide for 4 years ago. No, we said all ROS1 TKI developed to date are multikinase inhibitors, but yes, now we are having this new, for example, zidesamtinib is very, very specific to ROS1. Okay, so this can be probably the first totally specific for ROS1, and this may be very helpful in order to avoid side effects. If you see here in the table, some of the inhibitors inhibit TRK, and this is believed to cause the neurological symptoms, so we try to avoid this. And comparison of the activity of these inhibitors against different ROS fusions is lacking, and is still lacking 4 years later. We don't have enough in research on this. Novel type 2 inhibitors have the potential for greater selectivity. Pemetrexed is the more active chemotherapy for patients. This is still valid. Immunotherapy has not still formally been evaluated, but growing evidence of no important effect on this, and we need to validate clinical combinations. Okay, so these were my reflections like for 4 years ago, but what happens now with these new drugs? Okay, in San Diego a couple of weeks ago, it was presented the results of the efficacy and safety results of the TRUST-2 trial. This is a global trial. The TRUST-1 was only Chinese patients, and you will see here this. No, so patients must have non-small cell lung cancer, ROS1 positive, and they were randomized to different cohorts of. So naive patients were treated, and also patients with previously treated. So what are the results here? Well, as you can see here, very impressive overall response rate. These data are more mature than the one that I showed in the chart, but around 90% of responses, and also very important responses in the brain. So brain penetrating, very active. And also this is for the pretreated patients that have already received crizotinib or lorlatinib or other TKIs. And as you can see here, it still is very active, even almost 60% of response rates, and also in patients with brain metastasis. Safety, well, this is important. As we said, we have some dizziness. This is probably related with TRK inhibition. We have dysgeusia, and in my experience as a researcher in this trial, we are seeing the gastrointestinal problems. As you can see here, for example, diarrhea is present in almost 60% of the patients, and nausea 50% of the patients. So this is something that can pose a challenge, and in fact, some other doses, a little reduced doses, also tested. So, well, these were the conclusions on the presentation. This is a robust overall and intracranial responses. They compared efficacy between Asia and non-Asia population, because, as I said, the first data we have were only in Chinese patients. And, well, we don't have yet the PFS values, but it seems that they will be very substantial benefit for these patients. And, well, there are the side effects. The rate of neurologic side effects was low. This is something that we are worried. We compare, for example, with lorlatinib. And, well, this trial continues to enroll patients, so we will see more results on that. And this was a poster that was presented, and they were pooling the results of the TRUST-1 and the TRUST-2. But I will not just insist on this. This drug is active, very active. It's active in the brain. It works with some resistant mutations, but may have these side effects, gastrointestinal side effects or neurological side effects. And in a press release, the responsible for this the development of this drug, they were explaining that they are asking already for the FDA approval by the end of this year, and they hope they will have like the FDA approval for 2025. And also the drug has asked for the approval for the Chinese authorities, and they are trying to obtain worldwide approval by next year. We hope that this can be fast, but we know that the approvals sometimes can be time-consuming. And this is the phase 1/2 ROS1 study. Well, Dr. Bess is here. Maybe he would explain better than me his presentation. Sorry for using it. But what we would see here is that zidesamtinib is inhibitor that is very, very selective, trying to avoid any potential side effects related with blocking other proteins. Is the binding to the protein is covalent, so it's very, very strong. So it is also useful in many resistant mutations, and it's very penetrating. So what we have here is, as you can see, well, the patients that have participated in the phase 1 part of the trial with different doses, and the selected doses for the phase 2 is 150 milligrams. Patients were heavily pretreated. They have received chemotherapies. They have received several TKIs, including lorlatinib or repotrectinib. And well, as you can see here, for this heavy pretreated population, we have a overall response rate of 44%. And depending on the treatments they have received before, you can see. But for example, it's very interesting that for repotrectinib naive, but harboring this G20R32R resistant mutation, which is one of the most difficult mutations to treat with the inhibitors we have now, because it may be resistant to crizotinib, to entrectinib, and even to lorlatinib. Then you can see here that we have very nice response rates, 40% if you have received repotrectinib, or even 72% if you haven't received it. And these responses are also look to be durable, no? As you can see here, we don't have the duration of response, the median duration of response yet, reach the median, but we know that at least 70% of the patients can maintain the treatment for more than 1 year, as you can see, depending on the number of previous treatments they have received. Well, we can see here that we have brain activity, so we see responses in the brain. And about side effects, the main side effects are transaminitis. That is a very common side effect in all TKIs, and some peripheral edema, weight increase, but we don't see any other important side effects. So, well, these are the conclusions. And as we said, now the phase 2 of the trial is still ongoing, as including patients, and they have incorporated the ROS1 TKI naive. So they are going to try to understand the possibility of the use of this drug in patients that never received as a first line, as a first TKI line. Also, there is a cohort for any solid tumors, no? As we showed, there may be other tumors with ROS1 fusions, and these patients can participate in this cohort of the trial. This is the same, but a summary. So, yes, sorry, the thank you slide was mislocated. Well, I'm reaching to the end of my presentation. So can I stop the treatment? I have received this question many times for some of my patients. Some of them with ALK positive tumors or ROS1 positive tumors. And it's a very difficult question to ask, because they feel, sometimes fortunately, they feel very well with the treatment. They may have little side effects, and particularly they haven't received any previous chemotherapies or other aggressive treatments. They may have the impression that they can have a fully normal life. And sometimes, well, maybe they want to have children, maybe they want to do the kind of things that anyone without this kind of disease can do, no? So when we have this discussion, we can, of course, we know that until now, no drug has demonstrated that they can cure completely the disease. But why is this? How can we deal with this? No. So this very interesting paper from Jessica Lin was explaining about drug-tolerant persistent cells. No, this schema will try to summarize the problem. No. So as you can see here in the left, we have the treatment-naive disease. No, we have the lung cancer, and all these cells in blue are sensitive to the drug. So we can, or current standard clinical practice is that we do the therapy. Imagine that we detect ROS1 and we decide to use crizotinib, just to say. So we start to use crizotinib, and the drug-sensitive tumor cells will die. But then, at some point, there will be a cluster of tumor cells that are drug tolerant. They don't die. They can grow, but they don't die. So these are the drug tolerant persister cells. And with sorry for that. With time, these drug-resistant tumor cells, these drug-tolerant persister cells will mutate and evolve into drug-resistant tumor cells, and these drug-resistant tumor cells will drive the progression of the disease. So when we detect the radiological progression of the disease, we stop the current therapy and we try to analyze these resistant tumor cells, understand the mechanism of resistance, and show a new treatment. But the story will repeat and repeat again. So what was proposed in this provocative paper was that what if we can have a forward-looking paradigm, meaning that why don't we try to intervene on these drug-tolerant persister cells, which are the nest where the resistant cells will grow, no? So the idea is that we can do the initial therapy, but we need these new technologies like liquid biopsy, detecting circulating tumor DNA, radiomics, or multimodal models that integrate all this information. So we are able to detect the existence of these drug-tolerant persister cells, and we can design a strategy to destroy these drug-tolerant resistant cells. How can we do this? Maybe using radiation on these residual spots of the disease. This has been tried and showing some promise with the oligometastatic disease, no? After very good response with the initial drug, not wait until they become resistant, but try to terminate the residual focus. Or maybe we change the treatment, but the change in the treatment is based on the characteristics of these persister cells. Or we can do when the tumor is very is in residual form, try to boost the immune system with vaccines, etc., created based on the profile of these persister cells. And then we will try to understand if this way we can monitorize with liquid biopsy or radiomics any potential the effectiveness of these treatments that we are using when we can't see the tumor in the CT scans. Well, with this, I finish my presentation. I hope it has been useful and interesting for you, and I eagerly wait to see what Dr. Bese is going to tell us. Thank you. Thank you very much.
Thank you, Santiago Viteri. Thank you very much for your very useful and clear presentation. And now we are having Dr. Benjamin Besse to do the heads. Thank you.
Thank you very much for this invitation. It's always a great pleasure to talk to patients. So my presentation is about what to do at the time of TKI resistance. I will slightly overlap with Dr. Viteri presentation, but really slightly, and tell you what are the current options and what could be the future options. And for that, this is my disclosure, so the contract I can have with company, but the money goes to my hospital. And to talk about ROS1, we will talk about other type of lung cancer, because what we have learned, and I've started to treat lung cancer patients with lung cancer almost 20 years ago, and it was almost one disease, and we have discovered with all this alteration that it's no longer one disease but a spectrum of diseases, it is ROS1 is part of what we call the addiction. We know what is an addiction. Why we use the term addiction for tumor cells? You can be addicted to a drug or a compound or to smoke, and we say that the drug are addicted to a signal. And the first signal we have detected to be druggable is EGFR. EGFR was discovered 20 years ago. 2004, it was discovered to be predictive of the efficacy of the EGFR inhibitor. So I will refer a bit about EGFR because it's the oldest example of oncogene addiction we have in lung. So I think there is messages and that we can learn from this example that maybe will be applied to the ROS1 community in the future. So you know that when we said the drug, the cell is addicted, is because she depends so much on the signal to grow. And you know, cancer cells want one thing is to grow and grow and grow. That this signal tells the cells to grow. If you stop the signal, the cancer cell will either die, either stop to divide. When I present an oncogene addiction to my patients, I like to say it's the Achilles heel of the cancer, and this is where we will act. Of course, ALK was discovered as a second one, and then ROS1. So you have ROS1 receptors that give this signal to the cell to divide, and then the cancer want to grow and to grow again. So one thing that is not related exactly to resistance, but I think something important to cover is where does it come from? When we talk about this alteration, well, EGFR, ALK, ROS1, it's mostly in never smoker or light smoker. And why it happens in this population? Because what we know around the risk factors is that smoking is the major risk factor, probably to between 80, explaining 80 to 90% of the case of cancer. But for the ROS1 positive non-small cell lung cancer, usually they arise in patients that never smoked or really smoked a few years, and that's all. And what are the potential causes? So in a sense, as a patient with a ROS1 lung cancer is, why do I get this cancer? You can see that one of the lines is genetics. It means that you inheritate an increased risk to develop a cancer, but there is no family of ROS1 positive non-small cell lung cancer. It doesn't exist. You know, like a family where one woman out of two almost would have a breast cancer because there is a gene that is inherited, like BRCA1. It doesn't exist. So genetics, not so much. Radon is a gas that is prominent in some area, and Spain is an area where radon is very high in some area. It's not an issue when you live outside. It's a gas that is outside. It comes from uranium, but it can concentrate into the house, and the high exposure can induce a lung cancer. The big question is, does radon can induce a ROS1 positive lung cancer? So is this very particular radiation on the pulmonary cell is able to provide a ROS1 fusion in a normal cells that then will become a cancer cell? And that we don't know, but with Dr. Mesquita, we have done a large European study called BioRadon, where we gave to the patients radon detector to assess in their house the level of radon, and then a questionnaire to assess their lifetime history of exposure to radon. That might not be the only thing, obviously. We know that air pollution is the silent killer and might explain some of the lung cancer, but we don't know exactly, again, what kind of lung cancer it will induce. Will it be EGFR mutation? Will it be ROS1 fusion, ALK, maybe KRAS, something different? This is something really we have to understand, because I think for a patient, it's very important to understand what was the risk factor, if any, and how can I prevent others to get this type of cancer. Well, let's go back to resistance. What is the biology of resistance? It's very simple. But before going to, I just want to say that we always say that there is a biology behind resistance, and I will mention resistance mutation. But sometimes, maybe there is not enough drug in the blood. So this is a study we did in my hospital at Gustave Roussy, where we asked patients that receive at least 3 months of any type of TKI, tyrosine kinase inhibitor, if they would agree to be tested for the level of the drug in their blood. And we were very, very surprised to see that 61% of the patients tested had a level of the drug that was below the expected threshold. It doesn't mean it's not potent. I mean, maybe a very low dose is potent, but we were surprised to see that maybe dose matters. And there is one example with crizotinib, where a study shows that for the patients that have a higher level of the drug in the blood, there might be a higher duration of response. It's very preliminary. We don't have to escalate, but there is, for example, in the ALK field, a study called ADAPT-ALECT, where the patients start a treatment, alectinib, and then 15 days after they started the treatment, they have a blood test to assess the level of alectinib in their blood. And in those patients where the level is maybe a bit too low, the treatment will be escalated to reach the good level of the drug in the blood. The drug in the blood. I think it's very important study. It's really an hypothesis. I mean, don't rush to be tested for your crizotinib level. But I think that before thinking that cancer cells develop a resistance mechanism to a drug, I think it's important to say, is there enough drug to inhibit the cells? I think it's important. We sometimes forgot that. So regarding the biology, when you have this signal and you give an inhibitor, then you block the signal. This is why I put the arrows in red. But a resistance mutation can occur. And if I want to do it very, very simple, I would say that in ROS1, what we inhibit is the tyrosine kinase. It's an enzyme. Let's say it's a pocket where there is a lot of ATP inside. And crizotinib, for example, we go in the pocket and block the pocket. With a resistance mutation, the pocket will change, and then crizotinib will not be able to enter. So you can imagine, you can change the form of the pocket. Probably it's not exactly that, but then anyway, you have to design a new drug that is able to enter the pocket. And this is what we call the second generation inhibitor. And the hard-to-treat, and Dr. Viteri referred to that, the hard-to-treat one is called G2032R, but there are a lot of different resistance mutations. And where it's very complex is that sometimes you just don't have one resistance mutation, but 2 or 3. And then it's very difficult to understand when you have this complex mutation, we call them complex because there are many, what kind of inhibitor can be potent. And maybe if you go back to a different inhibitor, it will work again, but it's very difficult to anticipate this. Whatever, this resistance mutation is hard to treat one. And what we call the second generation inhibitors are the ones that can inhibit this one. And we have now many of them, repotrectinib, taletrectinib, NVL-520, we already referred to that. Importantly, cabozantinib, which is a drug approved for other type of cancer, such as renal cancer, in vitro and from case reports of colleagues in patients, can be an active drug after crizotinib or entrectinib. Repotrectinib is a drug we can sometimes access, that is a second generation that works in the cells and in the patients. So in pretreated patients, the first data we had is that this drug can work in patients pretreated with crizotinib or entrectinib. So we have, let's say, 2 generations of inhibitors. There was 2 weeks ago a presentation of what is the first-line treatment in France in patients with ROS1 positive cancer. And you can say that most of them receive still crizotinib. But at the time of resistance, we saw that repotrectinib is a drug that has clearly activity, and you can see it can be both post-crizotinib or entrectinib. Taletrectinib also has a good efficacy. Response rate is 55% in patients pre-treated. Interestingly, when you see that there is the resistance mutation, the famous G2032R, it's even more, 61%. ROS1, we already referred to that. Zidesamtinib, or NVL-520. In the study that was just presented 2 weeks ago, you can see that 38% of the patients had a secondary ROS1 mutations. And the activity of the drug in the pretreated patients was good, 44% of response. What is interesting is here, you can see ROS1 G2032R resistance mutation. In the patients that receive repotrectinib, 38% responded to the drug, which is interesting because it means that you are exposed to crizotinib, you develop the mutation is developed, this mutation is developed by the cancer cells, you give repotrectinib, you have some responses, and then you give also after repotrectinib this drug and you still have a good response. In the patients that went directly to zidesamtinib, the response rate was much higher. Obviously, the big question is what we should give as first line, because we are talking about resistance, but you can guess that if I develop a more potent drug, a stronger drug, maybe it's better to use it up front while we have an impressive duration of response with this new generation, but the best strategy is unknown yet. So at the time of resistance to TKI, let's what can we do? Well, we can use chemotherapy. Not so much data on that, but pemetrexed and platinum works. And you see here the median PFS, meaning the median duration of response, is 8 months, which is significant because it means that half of the patients have a longer response than 8 months. So let's not forget that chemotherapy is an active treatment, even if not the preferred one. It's a backup strategy at the time of resistance. For immunotherapy, very, very few data. We have these large European registries, only 7 ROS1 positive non-small cell lung cancer patients, and out of these 7, only 1 had a response to immunotherapy. And if you look at these curves, the green curves, where the patient seems to have the poorest benefits, are the ALK and the red positive patients. And rapidly, let's move to the other example, as I mentioned. So EGFR, there are 3 generations of EGFR inhibitor, develop a bit like the different generation of ROS1 inhibitor, but they have also discovered that sometimes the resistance is not driven by EGFR itself, but by something else. It's called off-target resistance, meaning that even if you still inhibit EGFR, the cell become addicted to something else. For example, a MET amplification. So there, the cell will develop a different addiction. And even if you are potent at VEGFR, you say, okay, you can inhibit EGFR as you want. Anyway, now my addiction is MET. And if MET is positive and activated, the cell will divide. So what should we do? Maybe we should inhibit both. And this is what has been developed with an antibody that block both EGFR and MET. This antibody is called amivantamab. It's what we call a bispecific antibody. So this drug is directed to 2 targets, EGFR and MET. And in the MARIPOSA-2 study, it's a study in patients that were exposed to the 3rd generation EGFR inhibitor osimertinib and then had a progressive disease. They could receive chemo or chemo plus amivantamab. And what we see is that chemo plus amivantamab increase the duration of response. So it works, not in all patients, but this is something very interesting. And maybe some of the ROS1 positive tumors resistant to inhibitor will develop resistance through an addiction by MET or something else that we could target in the future. So obviously, if it's working, maybe we should use it up front, and there are studies that use amivantamab from the beginning, so in untreated patient, and it seems to increase the duration of response versus the standard of care, osimertinib. Other strategies have been used, such as adding chemotherapy from the beginning with osimertinib, and this is also something we could imagine. Maybe to delay the resistance, we should combine chemotherapy plus crizotinib in some of the patients with ROS1 positive non-small cell lung cancer. Finally, and this is my last slide, on these antibodies, you can also plug chemo. So you will have an antibody that will recognize in EGFR, for example, and you plug on this chemotherapy, so you bring the chemotherapy directly into the cell. In the patient that resist to EGFR inhibitors, in fact, it's not EGFR, it's R3. It's a cousin of EGFR, and it's upregulated after osimertinib, and there is an antibody-drug conjugate, meaning an antibody against R3 plug with chemotherapy, and it seems that this kind of treatment is very interesting, and there is an ongoing phase 3 trial that combines this new treatment to a standard of care. No data on patients with ROS1 positive, but I think it's a very interesting field to explore in this population. Access to treatment, I will not mention that, but it is still a huge issue in Europe and a lot of disparity. And in conclusion, we know it's a rare disease. We have 2 generations and hopefully more to come. What is the best strategy? We don't know. Looking at resistance mechanism can be key, but it's not standard of care yet. You know, when you order a test, it must impact the way you treat patients. And today, knowing the resistance pattern will not impact so much the way we treat patients. It's really the research area. Don't forget that chemotherapy works, immunotherapy not with the current drug, and antibody-drug conjugate have to be explored. With that, I thank you for your attention. You are on mute, Stephanie. You are on mute, Stephanie. We cannot hear you.
Sorry. Thank you, Dr. Bejon-Maldès. Your presentation has been really appealing and helpful. So now we are going to introduce Meryl to the presentation. Thank you.
Thank you, Alex. You have my presentation? Yeah. Well, first of all, I'd like to thank the organization for organizing this webinar. Gives me, as a patient advocate, the chance to speak up. And hopefully this is the beginning of more webinars, especially for the rare oncogene-driven cancers like the red MET and the BRAF, etc. Thank you also for inviting these inspiring researchers. They are members of the Scientific Advisory Board of the ROS Wonders, the global ROS1 group. And all these new developments are really hopeful for all the patients that are listening. These sessions are very important to get informed, educated, and connected. And hopefully after this webinar, we have found new ways to collaborate. Like Santiago mentioned, he was referring to his 4 years ago webinar. In 2019, at the World Conference of Lung Cancer and in ESMO, I got the opportunity to speak about ROS Wonders. And in preparation of this presentation, I read these presentations again, and the gap between the national healthcare infrastructure and the lung cancer research is still growing, and at least it's not closing. So the gap is growing. The research is so much more advanced than what we are having at a national level. it took me quite some time to make this presentation because there are so many challenges we as ROS1 patients face, and but sometimes less is more. And today I want to tell you more about the need for ROS1 patients to collaborate with all patients involved. Next slide, please. Well, as you can see, the ROS1 fusion is rare. As an example, I just got the figures from the Netherlands, which we have a rather good registry. And this year, the incidence of ROS1 was 18 and the prevalence was 16. And that means that we have now 60 people alive, and we had 80 new ROS1 diagnoses. So that gives all kinds of challenges. We have small populations for clinical trials. We have less biomaterials for research, and we have huge disparities. NGS testing is not standard of care. We have heard two incredible clinicians from expertise centers, but in the rural areas, like Santiago already mentioned, a lot of doctors don't have any knowledge about ROS1. They don't have any knowledge about the right way to test or the access to have the right medication. There are disparities within a country, as well as when you are, for instance, when you're living in Italy, in the north, you have access to treatment, in the south, you don't. We talked about the second generation ROS1 inhibitors. In the Netherlands, for instance, we only have crizotinib reimbursed. So even if the EMA has approved a drug, it's not happening that the reimbursement will follow quite the same way. So the approval doesn't mean reimbursement. So it is, well, it's rather much. So we need to focus as ROS1 patients where we can have the largest influence and the biggest impact, because these are questions that are having bigger organizations to accomplish. And so we need to have a collaboration or a network with a local, national, European, and global groups to effectively advocate for ROS1 can be made. Personally, I think we have the right to have to inform and educate patients. We have, for instance, a global ROS1 Facebook group, and they are very informative and very educative, and your European ROS1ers can gather the information and translate it to the national language. We can collaborate with national patient organizations to start a ROS1 group, to make ROS1 patients aware that the existing social media groups, so that they can join, so that they are part of, well, the ROS1ers. Another thing that we as ROS1 on a European level can do is to collaborate with researchers. But all patients can help to elevate the ROS1 community. We can create, we can design, or together with researchers, we can design new research projects. We can navigate cross-border trials, because we are a rare cancer type, it is not common that in every country in Europe there are the same clinical trials. So if a patient needs to get another clinical trial, then he needs to go across the border. And sometimes that can be very, very harsh. Not every healthcare insurance will cover the cost of travel or the cost of the blood work, of their CT scan. So patients have to pay it out of their own pocket, but also patients have to speak a different language, and they have to travel, and they are having progression of disease. So it is quite an anxious times, and so maybe we can help them to navigate the cross-border trials. Next slide, please. We have some European challenges. We have a European flag, but we are not a United States of Europe. A lot of countries have a public healthcare system or a private healthcare system, or both. There are regional differences. A huge problem for us as patients to work across the border are the GDPR, and that is the privacy. We cannot just share every kind of information with each other. There are boundaries that we have to cross. So a lot of time when I spoke with my colleagues from the US, for instance, they thought that Europe was quite a unity, and that we were quite we were quite the same as the US. But if it is so different, so we have to overcome them. Next slide, please. So it is important that we build a united research advocacy voice. We have a ROS1 messenger group with the key opinion leaders from different countries. But I think it is important that we, even if we are fragmented in our own country, that we are coming together and be a voice of our own, so that we can really get access to the right clinical trials, to the right treatment, that we can have more awareness for other patients that they can be tested, that they should be tested. And for us, because a lot of treatment options we don't have, so we need to have more clinical trials, because, well, clinical trials may be for clinicians research, but for a lot of patients, clinical trials are the only way to get their treatment. So for us, clinical trials are not just research, they are treatment, they are hope. And so we need to work together. And this conference of lung cancer, my oncologist and I were asked to do a Meet the Expert session in San Diego. And we had to showcase our successful partnership between a patient and a researcher, and also to explain why it is important and why and how it can be successful to include patients within research, and especially patient research advocacy. First, we had to define what a patient research advocate is. Well, a patient research advocates provide the patient's perspective to researchers and research-related efforts. And luckily, there are two amazing programs to educate patient advocates in becoming a patient research advocate. So if you ever want to have more information, this is what you have to look for. We have EUPATI. It's the European Patients Academy of Therapeutic Innovation, and it has a European pan-cancer course. And what's the advantage of this course is that the course can be given in several national languages. So it can be given in your own language. And we have the STARS program, and that's from the International Study of Lung Cancer. And the STARS program stands for Supportive Training for Advocates on Research and Science. Next slide, please. So patient research advocates are important to be included in research. Most of the time, it's mandatory, but we're not a tick box. We really give relevance to and applicability. If there are more patient advocates involved, the outcomes will improve, the study design will be better, and there will be effective communication between the study program and patients that are involved, and it can bring trust. Patients are experts of their own life and know what the unmet needs are, and everyone can be an advocate, because even fundraising for research, but also very important, assessing patient information. A lot of time we hear that patients don't understand what the clinician is mentioning or what is saying. So the health illiteracy is rather high. So if we can translate the difficult information that the clinician has in something more in lay language, so that everyone can understand, and everyone has the need to understand what is going on with themselves. Next slide, please. Well, these are examples of research advocacy, interesting for ROS1 patients in Europe. The only thing that patients have in common is their disease. But the background, the talents, the interest, they differ, and can be used to have different kind of patient advocates and different types of advocates. And it would be great to share all the talents that we have and really make a difference. Next slide, please. If I mention our case in San Diego, this was the showcase. When I was diagnosed in 2014, Dr. Google didn't know anything about ROS1 and about rare cancer types. And because of the information gap, I didn't know what to ask my oncologist. So luckily, there was a new ROS1 Facebook group initiated, and I joined them, and it's so useful source to be informed about side effects, new treatments in pipeline, etc. And the group now has more than 1,200 members worldwide. A group within the group wanted to accelerate research, and we had a cancer model project. And the idea is very simple. Everyone was one patient who needed to have a biopsy, got in contact with a nurse. Nurse sent them a kit, and extra tissue was collected, sent to the lab in Colorado, and either cell lines or mouse models were created. Well, these were how it was explained to us. It was brilliant. Only Europe couldn't participate because the fresh tissue needed to be in the lab within 24 hours. So to raise money, you have a bank account, and to have a bank account, you have an organization. And luckily, I have a large network of friends with the right occupation. So I had my own foundation, Stichting Middelswereld. We made a website, and within a few months, I got an invitation from the board of directors of the Hansa University of Applied Science to have a cup of coffee. The Hansa was my employer at the time. And they have a motto, share your talent, move the world. And they said, you are doing it. How can we help? So it was kind of lucky that I got my own research project. I wanted the academic hospital, the UMGG, to be included, and together we came with a project to study end-resistant mechanisms for ocular and quite some similar project as the cancer model project. We had a new collaboration was born. Next slide. Well, we made lots of information materials. We made a video, the left side, it's not there yet, but we made it in Dutch, in German, in English, and in Spanish. We made brochures, and we had regional TV time, social media, etc. But it was not a piece of cake. We have these are the samples that we have collected so far. And for me, it's always so important that we integrated the research in education. So we have a lot of students that did their graduation projects. We had honors projects. For the next generation, people in the lab, they are more familiar with ROS1. We had cell lines off and off on target resistance. We got a beautiful cell line from Barcelona, and yeah, it's really a success. Except that patients who have progression are sometimes too anxious to think about research, so they think about it after they had their biopsy. We had some communications problems with patients, and we had doctors who didn't want to take an extra sample of tissue because they thought, well, who is responsible if everything, if something goes wrong? Next slide, please. So for me, if you have an idea how to build a European ROS1 research advocates group, if you want to help, please contact the AEACaP, or you can contact me. We can talk about what is the biggest unmet need, how to have the largest impact, how are we going to do it, what kind of structure are we going to do it, etc. Next slide. A long time ago, I told people that I was feeling like Don Quixote, along fighting the windmills, and it would be great to have a collaboration with people with the same purpose. Thank you.
Thank you, Meret. Your presentation has been inspiring and essential as a patient advocate. Thank you very much. So now I'm going to thank you again very much for this amazing presentation and for all the information you have shared with us. We are sure it will be useful, and our audience will be able to review it whenever they want on our YouTube channel. We have received some questions we would like to share with you, so you can give us your opinion or solve the doubts of the participants. So let's start with question time. We've got the first question from the different therapeutical approaches currently under study. Which do you think will be available in a near future to benefit ROS1 patients?
About the two trials I have explained in my presentation, the taletrectinib and the zidesamtinib, they are, well, as I said, there are like claims from the company saying that they are looking for the approvals for the agencies. They are going first for the FDA and Chinese in the case of taletrectinib, and also will be the same for the zidesamtinib, but they expect to have the first approvals in 2025, so next year. we know that it takes time, and we don't. And they say that they are going to look for these approvals in Europe too, but they don't state a particular date. So the probability of having these drugs, particularly the taletrectinib, that is more advanced because the phase 2 is data is going very well. I mean, the recruitment and they have already data, but I think will be next year minimum. I don't know, what do you think, or if you have more information, Benjamin?
No, I agree. I agree. There are currently clinical trials that are open in a few European countries where you can access the drug, and well, I think Michel referred clearly about the fact that it's not an easy thing, but it's doable to go to a different country and be enrolled in a clinical trial. It means there are rules to be followed. In particular, the patients need to have a form called the S2 form, which is a form issued by your country as a patient to have authorization to travel and to receive care in a different European country. I know that in some countries it's not very easy to get this S2 form. In other, it's maybe more easy. The second part is that in some country there is an early access program for second generation ROS1 inhibitor, in particular repotrectinib. So I think it's very important to, if you are at a point where crizotinib or entrectinib don't work anymore, to look for this opportunity, because again, with an S2 form, you can travel and get access to this form. So I think the ROS Wonder are really helpful for that, giving this kind of information for patients. It's true, I know that this webinar will be online, but it changes very, very fast. Some tigers show what we were thinking 4 years ago and what we think today. And you saw the field change, well, very quick for us. I know that for patients, it's never quick enough. It's a different temporality, obviously, but still, I mean, for 6 months from 6 months, we can have very different access to drug.
Thank you. So interesting to have so many information. Okay, we are gonna go for the second one. Since we speak about the possibility of having a vaccine for AEACaP biomarkers patients in the near future, is there any immunosuppressive therapy or vaccine from which ROS1 patients are normally excluded?
So this is a topic that the patients refer a lot to, vaccines, not only in the ROS1 community but in general. And we have now with the COVID crisis, we had improved so much in generating RNA-based vaccine and even personalized vaccine. A vaccine means that you try to learn to the immune system to recognize one specific, what we call epitope, which is a small part of one of the protein that is on the cancer cell. It's usually something to prevent the disease, but now we are talking about therapeutic vaccines. So far, I haven't seen data. I know that there are programs in the ALK field. What I can tell you is that if I take ALK, for example, there are, the ALK positive cancer are two main types, the ALK positive lung cancer, and there is one lymphoma in children that is ALK positive, and they respond to ALK inhibitors. And in these children, the most important prognostic factor, meaning the most important factor that tells you if the disease is aggressive or not, is the LDH level, which reflects a bit the bulkiness of the disease, and the presence of an antibody against ALK in the blood. And those children that have an ALK antibody, so it means that their body has recognized ALK as an enemy and was able to do some antibody, they have a better outcome. So this is something that we look in around 60 patients, because we have the technique in our lab, and we look in the blood of 60 patients with ALK positive non-small cell lung cancer, and only one of these patients had an antibody against ALK, and the medical history of this patient was not striking. It was not what we say an outlier compared to other patients. So it's really a dream to bring back the immune system in the battle, but it's not that easy. There are vaccines. There are also what we call cell therapies that may be also something important. Bispecific antibodies, I think we have a lot of tools now. It's true that the development we see is very different from TKI. There is a lot of development in all comers. So irrespective of the fact that you have or not a target, we don't see enough, I think, development in the population like the ROS1, ALK1, or EGFR.
Santiago, Mere, do you want to add anything?
Well, as Benjamin said, the immunotherapy, in fact, is a family of a new strategy to treat cancer. No, we try to reactivate the immune system so the immune system can destroy the tumor. But the kind of immunotherapy drugs that we are using in the practice have two main caveats. One is that it's very difficult to combine with TKIs. There is an increased toxicity when you try to combine with some of the TKIs we use in EGFR or in ALK. They have tried that. They have tried the crizotinib plus immune checkpoint inhibitors, which are the typical drugs we use now. And we see exaggerated toxicities. So these two kinds of drugs don't work well together. So this is a problem, important problem that we don't know how to solve yet. And then the second one is that it seems that this kind of immune checkpoint inhibitors work better in tumors that are affected by many mutations, particularly those caused by toxics, as Benjamin explained, like tobacco, smoking. So patients that develop lung cancer after smoking for many years, usually their cells are very accumulate a lot of mutations, and they are easy to recognize by the immune system. They are foreign to the body. But the ALK1, ROS1 oncogenic driver diseases, they don't carry so many mutations. So these cells are very similar to normal cells, and because of that, difficult to treat with the kind of immunotherapy we are using now. Probably, as Benjamin mentioned, personalized immunotherapy where you can extract the tumor and cultivate your cells, immune cells with the tumor and modify them to recognize this tumor in particular could be an opportunity, but this area of research is still very new. So we don't have any particular knowledge of something that is going on in ROS1.
Okay, Meret, should I go for the next question? Okay, so about the clinical studies mentioned on the RNA vaccine is related to it. So of the RNA vaccine of biotech going on in 7 countries, Spain among them, are there any more data you could share? Is it for patients with or without mutations, biomarkers?
And they usually, I can't tell you for sure. I've seen the news, the newspapers about this first RNA vaccine against cancer that is being tested in lung cancer. The first patient was a British patient that was treated, but I understand that this is for non-oncogenic driver positive patients. This is a very interesting field because as as it was mentioned during COVID, there was a huge advance in the way we can develop and synthesize vaccines. And from the very beginning, it was clear that this technology will also be helpful to create vaccines against cancer, because these RNA vaccines are very versatile, so you can model them to activate the immune system against certain proteins that may be only in the tumor. But as we said, probably there will be many more to come in the near future. It's a promising technology, but we have to see the first results yet.
Okay, let's go for the next one. Is there any T engager bispecific antibody, cell therapy, other approaches ROS1 patients could access to we should know about?
No, from my knowledge, there is no trial that is specific to ROS1 positive non-small cell lung cancer. I'm aware of one trial with cell therapy. It's a specific, well, it's a particular cell therapy. It's called TILS, which is something that is now approved in the US for patients with melanoma. But it's the study I know can enroll such patients, but it's only if they are or were smokers, which is not very common in ROS1 positive non-small cell lung cancer. It's a long process because you need to have surgery to remove enough cancer cells enough tumor, in fact, to send the piece of tumor to the lab, and the lab will extract what we call the TILs. So it's lymphocytes that are inside the tumors. And then when they are extracted, they are expanded and then put in a vial, sent back to the hospital, and this takes weeks. So it's really something, and it doesn't work each time. I mean, if there is not enough lymphocytes into the tumor, it doesn't work. So it's not an easy process, and it's not something you can receive 28 days after you sign the informed consent, like in most other trials.
Yeah, regarding bispecific antibodies or BiTEs, T-cell engagers, there is an interesting one, which is a BiTE that engages EGFR and some receptor for the T cells. So this is being tested in different cancer types: gastric cancer, pancreatic cancer. This is for a startup company called Affimed. There's a phase 1 clinical trial ongoing, and they are testing this in EGFR mutant. But interesting, they have also testing the BiTE in non-small cell lung cancer without the mutation, because the EGFR is not only the mutation that can, of course, when you have the mutation, you have an oncogenic addicted tumor, but other tumors use EGFR as an important receptor to grow, even if it's not mutated. It can be amplified, it can be overexpressed, or other. So the EGFR is frequently used in many tumors, and there is a lot of other therapies against EGFR, like antibodies, etc. So this BiTE is linking the T cells to the cells that have EGFR, and they are seeing responses in non-small cell lung cancer, and they are seeing interesting responses in EGFR mutant. So why I mention this? Because I think there are proteins that can appear in resistant ROS1, for example, MET, that also can be a way to mark the tumors. And for example, there are immunodrug conjugates against MET, that they link a chemotherapy but binds to the MET. And MET overexpression happens in ALK and even in ROS1. I have at least one case. So there are some drugs that are not specifically designed for ROS1 in this arena of bispecific antibodies, ADCs or BiTEs, but that may be helpful, or as patritumab, as Dr. Benjamin showed. Also, the topotamab deruxtecan, which is a new treatment, an antibody drug conjugate that binds to TROP2, that is a protein that is common in non-small cell lung cancer, and patients with mutations that have progressed to the TKIs, the inhibitors, and to platinum chemotherapy, can receive it and may have some benefit from them. But the mechanism of these treatments is chemotherapy, directed chemotherapy. No, this is one opportunity that can be helpful even in ROS1 patients. Don't need to be excluded for that approach. For BiTEs or bispecific antibodies, we may need to try, but there are no specific ones that I know that are directed against ROS1.
Okay, we've got 3 more questions left for the moment, so I'm going to go for the 4th. I think it's the 5th. I took crizotinib for 1 year, and now I am taking lorlatinib for 3 years. From the beginning of September, we have found a new 5 centimeters metastasis in my liver. Now I have to decide between 2 options. The first one is the ROS1 study you mentioned before, and the second one is resection. Could you please talk about the experience with ROS1 study? And until now, let me know what you think.
So in the ROS1 study, all the patients were pretreated by at least 1 TKI. So specifically in the patients treated with at least two TKI, the response rate was a bit higher than 40%. It doesn't mean that the other don't have a response, but it's just that the decrease do not reach 20%, which is our threshold to say it's a response or not. So it's a way to have let's say, an homogeneous way to report results, but for patients, what matters is to have a decrease of their tumors. Overall in the lung cancer field, but it's not for ROS1, it's true that each time that we have only 1 lesion that progress, we tend to look at local strategy. So keep the treatment that works on the other lesions and treat only resect the lesion. The thing is that we know that at one point the disease might recur, and then you will have to switch from lorlatinib to something else. I think it's very difficult to give any advice, obviously, in these cases, but the 2 strategies that have been offered are 2 very, usual strategies. One thing sometimes patients can fear is that, clinical trials are not open forever, and at one point, if the ROS1 study closes, the patients can say, well, did I miss an opportunity to receive the treatment? Since now the trial is closed, there is not any more opportunity to receive treatment. And this is, in that way, that might be a hard decision. And this is really a discussion between the patients and the clinician. In any way, the patient have to be responsible of such a strong discussion. One thing that we can say is that the NVL-520 or zidesamtinib, this drug, is one of the 2nd generation TKI, and in some countries there is access to repotrectinib, which is a potent 2nd generation. So it means that if the strategy goes to the local treatment plus continuation of crizotinib, and if the zidesamtinib trial close, there are still options, and I think in that case it should be also part of the discussion.
Okay, this question goes for Mary. From patient advocacy groups, can we help to improve equal access to treatments and clinical trials? How can we help?
How? I think the best way is to join a patient organization, because they have the real strength and the manpower and and all the means to become active, and they are the, well, at least in Europe, in our country, in the Netherlands, the patient organization is the spokesman for all patients. So if they want to have access to more treatment options, it is the patient organization. But because you are a member of the patient organization, you can be the spokesman for the patient organization with the policymakers. So it depends on how the infrastructure of your country is. But in Europe, the patient organizations are rather strong. I know in France, I know in Spain as well. You have a voice. So we are a fragmented group now, as ROS1 patients, but we can bring our voices together and change also national access programs. And I think that we should try it, because I think even the fragmented groups need to be more as a real group. So how can we, well, maybe we can build a network of ROS1 patients in Europe, a solid one. But most, I would say, become a member of your patient organization and try to have a ROS1 group in your country, so that you can have the access to the patient organization.
If I can share one experience, particularly with something that has happened and I didn't expect it, is that I have been contacted by some organization, in this case for EGFR exon 20 insertions, like recommending some patients for some trials. And I was positively surprised that this organization had a list of all the open trials on the field, a list of the centers that were open, and even they were like facilitating the contact of patients, no? So this has made that, as Benjamin was explaining, that some patients from different countries were arriving to a particular trial we had open at the moment. So I think this is very helpful, because sometimes it's difficult, even for us, for the oncologists, to navigate, to know which trials are open, where they are. Even in your own country, even in your own city, you may not be aware of all the trials that are open. So I think this is very valuable, no? As an advocacy group, giving the possibility to have this curated information on the trials that are open, etc. And this is in the interest of anyone, because the sponsor wants the organization to have this information. I think this is a good way to collaborate.
Yeah.
One important point. Oh, so sorry, please.
No, go ahead. But I think that this is the way that clinicians and researchers can work together with the patient groups, because we all have the same purpose, and so therefore the collaboration is really very useful for all.
One thing that is important when you enter a clinical trial that is far from your home is to check with the sponsor of the trial, so that this is the job of the physician or the investigator, of course, but how the expenses of the travels will be covered, because what we don't want also is to have too much out of pocket expenses, and sometimes they cap what they give to the patients, but there is a margin to be negotiated. So that's also, I think, important to bring that really soon in the discussion when you want to enter a trial in a different country.
But maybe if I can say something, if you are negotiating the trial with the sponsor, maybe there can be some kind of a nurse navigator to be included for patients from abroad to help them to get access to the trial.
Okay, we have two more questions, but I think this one is already related with what you have mentioned now. How could we better collaborate patients and researchers? So we are gonna go for the last one. This one is for Dr. Benjamin Bess. Could you tell us more about Koala French project? It says, could you tell us about Koala French project?
The Koala French
Koala.
project.
I don't know.
I think
We see. No, it's like we see.
I think it's a, if I'm not wrong, it's a project that is led by one of my friends, Julien Mazière, and it's a grant that has been it's a national grant to boost research on lung cancer, and part of the what we call the work packages, which is the different task that you have to do in such grant, is linked to the what we call oncogene addicted lung cancer. But it's really research, and I'm not sure there is a direct impact for the patients today, but I hope it will bring ideas to develop drug tomorrow.
It will bring, for sure. We just have to wait, but not a lot. Okay, so with this last question, we are gonna close because unfortunately we don't have no time for further questions. So we are gonna close today's session. I cannot finish without thanking, first of all, Dr. Santiago Vitelli, Dr. Benjamin Bess, and of course, Meryl Heinig, on behalf of myself, as a patient, and as AEACaP, of course, the people who are part of the association for the time you have dedicated to us. I would like also thank the industry that made today's webinar possible, and last but not least, the participants in this activity. Many thanks to everyone, and thank you very much again, and see you at the next webinar.
Thank you.